Greetings, class. My name is Innocent MAPANDA. Thank you for tuning in to your favorite channel. In today's lesson, we are going to focus on division of complex numbers with powers, right? We are given 1 plus I to the power of 4 divided by 2 minus 2i to the power of 3. And the question is requiring you to express this in the form x plus iy, where x is the real number and yi is the imaginary part of the complex number. So we have various approaches that someone can make use of. The first approach is to tamper with your denominator 2 minus 2i so that it becomes a common base with the bracket above 1 plus I. So what I'm going to do is I'm going to take 2 minus 2i to the power of 3 first. Then you put a big bracket. You factor out 2 outside the bracket. Then you say 2 into 2, you get 1. 2 into minus 2i, you get minus I. Then you close your bracket, raise everything with power 3. I hope you are following. So we now need to make 1 minus I to be a common bracket with 1 plus I. For 1 minus I to be a common bracket with 1 plus I, you factor out minus I so that you get 1 plus I. In simple terms, we are saying 1 minus I is equivalent to minus I, 1 plus I. I hope you are following. This can be tested. Let's say you want to expand this bracket. Minus I times 1, you get minus I, right? Then minus I times I, you get minus I squared. But remember, I squared is good as minus 1, right? So you get minus I minus open bracket, I squared is minus 1, which is good as minus I plus 1, which is good as 1 minus I. I hope you are following. So in simple terms, 1 minus I is equivalent to minus I open bracket 1 plus I. Why are we using this form? We want the denominator and the numerator to have a common bracket which can cancel off each other. I hope you are following. So in simple terms, I'm going to proceed by simplifying this big bracket. You write 2, this 2 first, then you put open bracket, you put minus I, this minus I, then you put 1 plus I, then you raise everything with power 3. I hope you are following. So this negative I and 1 plus I are equivalent to 1 minus I. I hope you are following. So according to the laws of indices, this power 3 is going to raise everything inside the bracket. So if 2 is raised by power 3, it gives you 8. So you write 8 here. Then minus I is going to be raised by power 3. So if minus I, right, let me work it here. If minus I is raised by power 3, you get minus I times minus I times minus I, where minus I multiplies itself 3 times. So minus I times minus I, you get I squared times minus I. I hope you are following. But I squared is good as minus 1. So minus 1 times minus I, you'll be left with I. Since negative and negative, they produce a positive result. I hope you are following. So in front of this 8, I'm going to put an I, something like this. Then 1 plus I is going to be raised by 3. I hope you are following. So 8i, 1 plus I to the power of 3 is going to represent our new denominator. Right, so you can notice that 1 plus I to the power of 3 is a factor of 1 plus I to the power of 4. So if 1 plus I to the power of 3 enters into 1 plus I to the power of 4, you get 1 plus I. So I'm going to write 1 plus I divided by 8I. I hope you are following. So to clear off the complex component on the denominator, you have to multiply both the numerator and the denominator by the conjugate of the denominator. And the conjugate of 8I is minus 8I. So I'm going to multiply by minus 8I on both the numerator and the denominator. I hope you are following, class. Right? 1 times minus 8I, you get minus 8I. Then I times minus 8I, you get minus 8I squared. But this is going to become plus 8 since I squared is minus 1. Take note of that. Then we move on to the denominator. 8 times minus 8, you get minus 64. Then I times I, you get I squared. Meaning to say that minus 64 is going to become plus 64 since I squared is minus 1. Right. So I'm going to write 8 since minus 8 times I squared, you get 8. Then you put minus 8I, the imaginary, in the second place. Then you divide everything by 64. Since minus 64 times I squared, you get 64. I hope you are following, class. So to get your final answer, you are now distributing 64 to the left and to the right. You get 8 over 64, right, minus 8I over 64, something like this. So you can notice that this can be reduced in its lowest terms if we divide by 8. 8 into 8, you get 1. 8 into 64, you get 8. Then 8 into 8, you get 1. 8 into 64, you get 8. Then you put I. And this is your final answer. I hope you are following, class. I hope you enjoyed today's tutorial. Till we meet again, shalom.